Hi friends, welcome back to our loving channel Sea Level Physics. My name is Srinivas, known to be BS Rao. In this video, we are going to start one new lesson, that is motion in one dimension. Okay. In this lesson, we are going to deal some new terminology, means new factors or new quantities like rest, motion, distance, displacement, speed, types of speeds, velocity, types of velocities, acceleration, types of acceleration, frame of reference, and types of frame of reference, etc. Okay, first of all, we need to discuss what is meant by rest. See, rest, what is meant by rest? Suppose the position of particle does not changes with respect to surroundings or time, then that particle is said to be at rest. See, position do not changes with respect to surroundings or time, then the particle or that body is said to be at rest. Coming to motion, when do we say that a body is under motion? Means if position of that body or particle changes with respect to time or with respect to surroundings, then that particular body is said to be under motion. Say position changes with respect to surroundings or time. Okay. Now same can be realized by using one simple example, say as shown in diagram. Suppose here we have a truck which moves with velocity 20 kmph. See, here A and B are two co-passengers in that truck. A, here it is B. So these two persons. Here see, outside on the ground, one man C is standing. Standing in the sense velocity is 0. That is, he is at rest with respect to ground. With respect to ground, person C is at rest. With respect to ground, truck is under motion with a velocity of 20 kmph. Okay. As far as ground is concerned, person A, person B, and truck also moves with the same velocity 20 kmph, kilometer per hour. Am I right? As an example, I am taking A is the man under study, and B and C are observers. See here, B is one observer inside of that truck, moving truck, and C is one more observer who is standing outside of the truck, somewhere here on the ground, right? So B, C are observers, A is man under study. So these two persons are going to study the state of that man, right? A, man A. Suppose as far as B is concerned, what is the state of man A? Let us discuss first. See, as truck is moving with velocity 20 kmph with respect to ground, person A and person B also moves with the same velocity with respect to ground. Right? So a frame attached to truck is identical to a frame attached to B, also identical to a frame attached to A. Means if A moves with a velocity 20 kmph, B also moves with the same velocity 20 kmph. So as far as B is concerned, so with respect to B, what is the state of person A? Means rest, natural rest. See, with respect to B, person A is at rest. That is the state of A with respect to B. Why? Because frame attached to A or B are identical. Okay. As A moves with 20 kmph, B also moves with the same 20 kmph along with the truck with respect to ground. So that is the reason why B observes as if A is at rest. Okay. Now coming to C. See, person C is standing outside of the truck somewhere here on the ground. Am I right? So standing in the sense his velocity is 0. What is the velocity of a person C? 0. Right? With respect to C, what is the state of A? See here, with respect to C, truck as well as A, B, all the three are in motion. Why? Because a frame attached to C is different from a frame attached to truck. Am I right? So that is the reason why with respect to C, the velocity of A is 20 kmph in forward direction. So that is the reason why what is the state of A with respect to C? Means motion. So C finds as if A moves with the 20 kmph in forward direction. So what is the state of A with respect to C? Means in motion. Right? Now see, both B and C are observing same person A. but be observed to be A is at rest, but C observed to be A is in motion. Means same person appears to be different for both observers. For both observers C, B and C. Right? What makes the difference here means, what makes the difference? B finds A is at rest, C finds A is in motion. Okay. Both B and C are observing same person A, but result is different. Why result is different in the sense? See, if you observe, the velocity of A is the same as that of B. Why? Because with respect to ground, the velocity of A is 20 kmph, the velocity of B also 20 kmph. So with respect to ground, both are in motion, right? So if you attach the two frames for B and A, both are identical. That is the reason why A appears to be at rest with respect to B. But if you attach one reference for C, that is different from attaching reference to A. That is the reason why C observes A is in motion. Right? So here, same year appears to be different for both observers. So with respect to B, A is in motion. With respect to B, A is at rest, but with respect to C, A is in motion. So what is the inference here? Nothing is in absolute motion or nothing is in absolute rest. That is one thing. So we came to know that nothing is in absolute motion. No body is in absolute motion. So of course, one body appears to be in motion with respect to one observer, but the same body appears to be at rest with respect to some other observer. That is the reason why what I am saying means nothing is in absolute motion or absolute rest. Coming to another point, motion is the combined property of body under study and the observer. Motion is the combined property of body under study. See, A is the person or body which is under study with respect to B and C. But with respect to B, A is at rest, but with respect to C, A is in motion. So that is the reason why what I am saying means motion is the combined property of body under study and the observer. Okay. That property motion, the property motion is not belongs to unique body. That depends upon both observer as well as body under study. That is the important thing to note. Coming to another point, rest and motion are relative but not absolute. But not absolute. Rest and motion are relative. Means A is at rest with respect to B. With respect to B in the sense relative to B. But the same A is in motion with respect to C. Means relative to C, A is in motion. That is the reason why we can say that rest and motion are relative but not absolute. But not absolute. Okay. Right. Coming to frame of reference. What is meant by frame of reference? Suppose if you want to study position or an event occurs in nature, we need of one background with respect to which that observation should be done. That background with respect to which observations are made is known as usually reference frame or frame of reference. Okay. Let us see frame of reference. Frame of reference. Frame of reference. What is meant by frame of reference? It is the background from which observations are made. It is the background from which observations are made. Frame of reference. Frame of reference means it is the background from which observations are made. Suppose here B and C are both observers who are going to observe state or motion of A. Am I right? So if you attach one frame for this C, frame in the sense usually it is system of Cartesian coordinate axis. Say this is x-axis, this is what y-axis, this is what z-axis. Okay. If you attach the system of Cartesian coordinate axis to this observer with that observer as the origin, then that becomes a background. Okay, for the sake of observations. So this man is going to observe the state of A. Now we need to attach one system of coordinate axis with that observer as the origin. Now itself, this diagram itself, frame of reference. This background itself, frame of reference. Suppose here B also observer, who is going to observe state of A. Then take one Cartesian coordinate axis like that. Okay, say x-axis, y-axis, z-axis. Now a frame is attached to observer B. Okay, making use of this frame, observer B is going to observe state of A. Okay, so usually what is meant by frame of reference? Nothing but a background from which observations are made. Usually it is system of Cartesian coordinate axis. System of Cartesian coordinate axis. System of Cartesian coordinate axis. Am I right? Axis. This is nothing but frame of reference, right? That is what region to make observations. This is what usually region to make observations. Suppose if you attach one frame of reference to this moving vehicle somewhere here, say x-axis, this is what, y-axis, this is what, z-axis, like that. I am going to attach a frame of reference, a Cartesian coordinate axis, somewhere here to the moving vehicle, say x, y and z. Now, with respect to this background, we can study both A and B. We can study position or motion of persons A and B. Am I right? So, we came to know that frame of reference in the sense a background from which observations are made. Otherwise, region with respect to which observations are made. Usually it is a system of Cartesian coordinate axis. Say something like x, y, z. Okay, with the observer as the say this observer as the origin for this system. Am I right? Okay. Now, how many types are there in frame of reference? Usually, two types are there. What are the types here? First one, inertial frame. Inertial frame. Second one is non-inertial frame. Inertial frame, non-inertial frame. What is meant by inertial frame? Suppose if observer is at rest, then a frame attached to that observer also at rest. Suppose if observer is in motion, then a frame attached to that observer also in motion. Okay. Now what is meant by inertial frame? Means if observer is at rest, then that observer is said to be inertial observer. Right? Right. If observer is in uniform motion, means moves with uniform velocity, then also that observer is said to be inertial observer. In that case, in both cases, that frame is said to be inertial frame. Means if frame is either at rest or moves with uniform velocity, then that frame is said to be inertial frame. See, here man C is at rest with respect to ground. Now, a frame attached to ground or a frame attached to this person is to be taken as inertial frame. Suppose if man C moves with uniform velocity, either that direction or this direction, whatever it is, then a frame attached to that uniformly moving person also said to be inertial frame. For example, if this truck is moving with uniform velocity, then a frame attached to that uniformly moving truck also said to be inertial frame. Otherwise, if truck is at rest, then also a frame attached to that stationary truck also said to be inertial frame. So, what is meant by inertial frame? It may be either at rest or moves with uniform velocity. At rest or moves with uniform velocity. Okay. Any frame of reference, either if it is at rest or moves with uniform velocity, then that is to be taken as inertial frame of reference. Now, what is meant by non-inertial frame of reference? The same frame is under acceleration or deacceleration, then that frame is said to be non-inertial frame of reference. Suppose a person C moves with the acceleration, means with increasing speed. Otherwise, deacceleration means, and retardation means with the decreasing speed, moves with the decreasing speed. Then a frame attached to that accelerated person or accelerated truck or accelerated car or deaccelerated person, then that frame is said to be non-inertial frame. So what is the criteria here? Accelerated or deaccelerated frame, or deaccelerated frame. So accelerated frame or deaccelerated frame is said to be a non-inertial frame. A frame which is at rest or moves with uniform velocity is said to be inertial frame. That is how we can have two frames. One is inertial and another one is non-inertial frame. Now coming to next point. How many types are there in motion? How many types are there? How many types are there in motion? Here we have three types are there in motion. Three types. First one is one-dimensional motion. Second one is two-dimensional motion, and third one is three-dimensional motion, based on the path followed by the particle under motion. Am I right? First one, types of motion. See, types of motion. We have three types. One-dimensional, second one two-dimensional, and third one three-dimensional. One-dimensional motion, two-dimensional motion, and three-dimensional motion. Alright? What is meant by one-dimensional motion? Our chapter name also one-dimensional motion. Motion in one-dimensional. What is meant by one-dimensional means a particle is under motion along a straight line, then that motion is said to be one-dimensional motion, otherwise straight line motion, otherwise rectilinear motion. So two more names for this type of motion. What is the other name? Straight line motion, otherwise rectilinear motion. Say once again, one-dimensional motion or straight line motion or rectilinear motion. So three names are there for this kind of motion. Suppose a particle moves along a straight line. Say particle moves along a straight line from A to B. See the path. This is a path followed by a particle along straight line. Then this kind of motion is said to be one-dimensional. Right? Of course, the same particle moves in a plane along a straight line, then also we can say that straight line motion or one-dimensional motion. See, this is what XY plane. XY plane. Here, this is the path followed by the particle. See the path. What is the shape of the path? Straight line from A to B, for example. From A to B. See, this is the path followed by the particle from A to B. Of course, particle is in moving in a plane, XY plane, but if you observe the path, that is straight line from A to B. Straight line. Okay, the path is straight line, whether it is moving in plane or otherwise. That path is said to be straight line path, and motion is said to be one-dimensional motion, otherwise straight line motion, otherwise rectilinear motion. Okay, right? Now, the path is like that. See X, Y. This path is like that. There are also straight line motion. The path is like that. From A to B. Path is like that from A to B in XY plane. Even though a particle is moving in a plane, as far as shape of the path is concerned, as it is a straight line, then this is to be taken as example for straight line motion, otherwise rectilinear motion, otherwise one-dimensional motion. Right? Now, what is meant by two-dimensional motion? If a particle moves in a plane along any curve other than straight line, then that is said to be two-dimensional motion. Okay. See, this is what two-dimensional in the sense. Example. See, this is what XY plane. In this XY plane, a particle is going to move like that. See, is it curve or not? Yes, curve. It is other than straight line. Right, other than straight, it's not straight line path. It's not straight line path. That is curved path. Moreover, it is moving in a plane with along a curved path other than straight line. Then that motion is said to be two-dimensional motion. We can say oblique projectile. Suppose this is what oblique projectile. When body is projected like that in XY plane, like that, because of gravity it takes parabolic path. Right? Here x and y coordinate changes. Both x and y coordinate changes with respect to time. Moreover, path is parabola, means one curved path. So it's not straight line. That is the reason why this is example for 2D. Similarly, horizontal projector. Suppose this is what a tower. This is top of the tower. A body is projected horizontally from the top of the tower. Now, because of gravity, it takes path like that. Now, see, this is the path followed by the projectile, oblique projectile. Now, this is also example for curved path. Moreover, both x and y coordinate changes here. So, therefore, this is also example for two-dimensional motion. One more example, usually we shall come across in future, that is circular motion. Circular motion, also example for two-dimensional motion. Circular motion. Suppose motion of particle along circle like that. Motion of particle along circle. This is also example for two-dimensional. Why? Because this is a planar motion basically. Right? Planar motion. If body or particle moves along a plane, along a curved path, then it is two-dimensional motion. So this is also, in this case also particle moves along in a plane along a curve. Curve in the sense here circle. So this is also can be taken as example for two-dimensional motion. Now coming to three-dimensional motion. What is meant by three-dimensional motion? Three-dimensional in the sense here motion is not confined to any plane. Something like zigzag path. Path may be zigzag, means not confined to any single direction or single plane. So it confined to all the three planes in a zigzag manner, then it is said to be three-dimensional motion. See, this is what XY Z axis, X, Y, Z axis. Now a particle moves along XY plane initially and emerging normally from the XY plane line. Here dot in the sense particle is going to emerge normally from XY plane. See, this is what curved path in XY plane. Moreover, here from this position emerging like that outside. See, like that outside. Okay, right? It is what one fly is going to fly like that along this path in XY plane and from it emerging normally outside. Means here motion is not confined to any plane. Of course, here confined to XY from here to there, XY plane, there onwards in some other plane. Means not confined to any single plane here. Right? So that kind of motion is said to be three-dimensional motion. Suppose motion along X, Y, Z. Motion along X, Y, from which along Z means dot. Dot in the sense outwards. Along X, along Y means parallel to X, parallel to Y and parallel to Z. Dot. Parallel to Z in the sense dot. Outwards, normally outwards. Right? So that kind of motion. If motion is not confined to any single line or single plane and confined to different planes in a zigzag manner, then that kind of motion is said to be three-dimensional motion. Three-dimensional motion. Okay, right? Now, coming to next point. Next quantity worth to know, that is distance and then displacement. What is meant by distance or displacement? Distance. Coming to first quantity, that is a distance. See, distance. distance, right? Next point, distance. Say symbol D as an example. You can take symbol, any other symbol also, either S or R, otherwise D, etc. So distance. What is meant by distance? Suppose a path is going to take path like that from A to B, like that. From A to B. This is the path followed by the particle. Say curved path. This is what curved path. Now A is the initial position and B is the final position, right? Final position. Now when a particle is under motion, or otherwise when a body is under motion, the total length of the path is said to be distance. The total length of the path covered by that particle, moving particle, is said to be distance. Total length of the path. Total length of the path is known as distance. The total length of the path is known as distance. How to measure distance? Take one tape and place somewhere here on the usual path, actual path followed, like that. See, this is the actual path followed. Say this is one tape. Place one tape on the actual path followed by the particle, like that. Now see, this is the scale, like that. Spread the scale on the actual path followed by the particle, okay, from initial position to final position, right? Place on the path followed by the particle. Place that tape on the path followed by the particle, like that. Now make it straight to get the total length. Make it straight like that. See, make it straight like that to get the total length. Total length from A to B. Make it straight to get the total length. Now that itself, the total length of the path followed by the particle, that itself distance covered by that particle in a given time interval from A to B, right? Here distance depends upon the actual path followed. Depends upon actual path followed here. Depends upon, distance depends upon actual path followed by the path, right? Here distance depends upon the actual path followed. Whatever the turnings are there in its path, we have to include every turning while calculating distance. So distance depends upon actual path followed by the particle. Now moreover, it is a scalar quantity. It is scalar quantity. It is scalar quantity. Scalar in the sense it has no direction. Distance has no direction but has magnitude. No direction. No direction. I am writing somewhere here. It has no direction. Only magnitude. No direction. Has only magnitude. Right. For a moving particular body, distance never be zero, never be negative, always positive. Important point here also. Distance never be negative or zero, for moving particle, but always positive, always positive. So distance never be negative, never be zero, but always positive for moving particle, not for stationary particle. Moving particle, okay. For moving particle, whether it moves forward or backward, distance always additive, not subtractive. Distance always additive with a positive sign. Okay. Distance always additive with a positive sign, but not negative. but not 0. Always positive for moving particle. Moreover, it is a scalar quantity. Depends upon actual path followed. One more thing worth note, that is it is real or absolute. It is absolute or relative. Now only I told you that it is relative quantity. It is relative. It is relative quantity. It is relative quantity. Means when a particle is under motion, the distance covered may be varied from observer to observer, or may be varied from one frame to another frame. That is the reason why it is said to be relative quantity, not absolute. Am I right? It is not absolute, relative quantity. Now coming to units. SI units. Suppose I am rubbing somewhere here. What are the SI units for distance? What are the SI units for distance? SI units, I am writing somewhere here. SI unit, that is meter. METRE, symbol small, meter. CGS units. CGS unit, that is centimeter. That is centimeter. Am I right? So that's about distance. So what is meant by distance? The total length of the path covered by a moving particle is said to be its distance in a given time. Right? It is always additive. It never be subtracted. Always additive. While calculating for a moving object, distance always positive. Always positive. Never be negative. Never be 0. But always positive. Am I right? Now, what is meant by displacement? What is meant by displacement? Say displacement. Displacement. Say S bar. It is vector quantity. That is the reason why I am taking bar, S bar. Displacement. What is meant by displacement means when a body is under motion, right? A line segment drawn from initial position to final position, irrespective of path followed, is known as displacement. See here, this is the actual path followed by the particle from A to B, right? Now take one line segment like that. Take one line segment from initial position to final. See, this is initial position, this is what final position. Take a line segment like that. This is what a line segment. This is what one line segment. Without considering its path followed, actual path followed, if I take a line segment drawn from initial position to final position with an arrow, then that is nothing but displacement. Right? This is what displacement like. See, this is the actual path followed. Actual path followed from A to B. Right? If I join initial position and final position with a line segment from initial position to final position like that, this is what displacement, S bar. So while calculating displacement, no need to consider actual path followed. Whatever the shape of the path, simply we neglect simply the path followed. Simply we have to consider a line segment drawn from initial position to final position. See, this is the shortest distance while joining initial and final positions. Of course, we can join A and B like that, or like that, or like that. Among all, this is the shortest path, right? This is what shortest path in joining initial and final positions. Okay, this is the shortest path in joining initial and final positions. Shortest path. So it could be shortest distance also. Okay, while joining initial and final positions. So the shortest distance between initial and final positions, also known as the magnitude of displacement. Magnitude of displacement. Am I right? Magnitude of displacement. Now, what is meant by displacement? When a particle is under motion, a line segment drawn from initial position to final position, irrespective of path followed. Irrespective of path followed in the sense, we are neglecting the actual path followed. This is the actual path followed. We are neglecting the whatever the path followed. Simply, I am joining a line segment from initial position to final position with an arrowhead. That itself displacement. Right? So it has magnitude as well as direction. What is the direction from initial position to final position? So what are the characteristics of displacement here? See, SI unit meter, CGS unit centimeter. Here also SI unit meter symbol smaller, CGS unit centimeter small cm, right? Is it relative or absolute? Means this displacement also changes as per the frame of reference. With respect to initial frame, it may be it could have one value. With respect to non-initial frame, it could have another value. So that is the reason why it's not absolute. That is relative. So it is relative. It is relative quantity. Alright. So it depends upon, that means to say that depends upon frame of reference. It depends upon same as distance. It depends upon a frame of reference. Frame of reference. Does it depend upon path followed? Means no. Displacement never depends upon path followed. Whatever the path, we neglect the path. We have to consider initial and final positions. That's all. In a straight way. So independent of path followed. Am I right? Coming to another point, that is it has both magnitude as well as direction. Moreover, it can be split up into components. Means it obeys parallel rule of addition. Therefore, it is vector quantity. It is vector quantity. It is vector quantity. But displacement may be positive, may be negative, may be zero for a moving object. So it may be positive or negative or zero. Displacement may be positive or negative or zero for a moving particle. Right? Suppose a particle moves like that from A to B, like that, again from B to C, retracing like that, B to C. Suppose a particle moves from A to B in a straight line, again from B to C, like that, means retracing. Suppose this is S1, this is S2. From A to B, path length S1, from B to C, path length S2. Now what is the distance and what is the displacement? So distance D equal to total path length. See here, the total length of the path is known as distance. What is the total length of the path? Means AB plus BC. That is S1 plus S2. S1 plus S2. Right? S1 plus S2. Coming to displacement S. Displacement S. S in the sense, see, the A is the initial position, C is the final position. A is the initial, C is the final. Now, a line segment drawn from A to C. This itself, this AC bar itself, displacement. It's not AB bar, or it's not AB, it's not BC. Now, what is meant by displacement? AC only. AC in the sense that is AC. AC in the sense S1 minus S2. S1 minus S2, that's all. This is what displacement. Okay. This is what displacement. Am I right? So distance in the sense total path length, that is S1 plus S2. Displacement in the sense a line segment drawn from initial position to final position. What is the initial position? A is the initial position. What is the final position? C is the final position. B is not final. C is the final. So as per as definition is concerned, a line segment drawn from initial position to the final position. Initial position to the final position. This is what? White arrow. That itself displacement. How to get this measurement? Means S1 minus S2. Right? So in this case, distance is greater than displacement. Distance is greater than displacement. Am I right? See, distance in the sense S1 plus S2. Displacement in the sense S1 minus S2. Means distance may be greater than displacement. Of course, distance may be equal to displacement also. How to realize that point? How to realize? Suppose the particle moves along a straight line without returning back like that. See, A to B. A particle moves from A to B along straight line. In this case, what is the path length here? Say S. So distance equal to S. Total path length S. Distance equal to S. Now what about displacement? Displacement also S only in this case. Why? Because a line segment drawn from, see, this is the path followed by the particle, straight line. Say this is L otherwise. L. See, L is the total path length for a moving object from A to B. See the path, straight line path. As far as the distance is concerned, what is meant by distance here? Means path length. Total length of the path. That is, L is the path length. Right? Now what is the displacement here? Displacement S equal to, say, symbol S, displacement equal. Distance equal path length L. Displacement is nothing but shortest distance in joining initial and final position. See, this is what initial position, this is what final position. So, path also same only. A line segment drawn from initial position to final position also same. Both are coinciding here. Right? Line segment joining from initial position to final position, arrow mark, coinciding with the actual path followed. Means the magnitude of displacement becomes equal to distance. So, displacement also L. So, in this case, distance and displacement both one and the same, provided path is straight line and moreover direction is not changed. Direction is not changed here. Direction is not changed from A to B only, not returning back here, not retracing here. That is direction from left to right on. Here not at all returning, not at all retracing its path. So in that case, a particle moves forward along a straight line. In that case, distance always equal. In that case, distance becomes equal to displacement. In all other cases, distance greater than displacement. So if we club both points here, distance is greater than displacement here. Distance equal to displacement. So on clubbing both statements, distance always greater than or equal. Here greater, here equal. So distance may be greater than displacement. Distance may be equal to displacement, but distance always greater or equal to displacement. This is one important relation. What is that relation? Distance always either greater or equal to displacement, but never, distance never be less than displacement. Okay, distance never be less than displacement. Distance may be equal to displacement or distance may be greater than displacement, but distance never less than displacement. Okay friends, once again I requesting all the audience, please don't skip the video, watch till the end and subscribe my channel C Level Physics. Share my videos, like my videos, comment on my videos. Thank you friends.